All right, so we were done with the first three assumptions. We're going to start working through the more straightforward ones, especially these next couple are going to be super fast. So variable costs are 45% of revenue. So as revenue goes, variable costs grow. So nothing crazy here. I'm going to move salvage down a little bit. I don't need it so close anymore. So we should be here on the model, and I can start going down the assumptions. So variable costs. 45%. So I'm just going to plug that in there. Variable costs are 45% of revenue. So you just multiply revenue by 45%. Go ahead and lock that 45% with that 4. And then I can go up here, Control over, Control Shift left, Control R. So just fill everything over. And we're good. So there's variable costs. So nice and easy. Everybody likes variable costs. Fixed costs. So for the plant, will be $3 million per year, starting in year 2. 6.7, almost 6.8 million in year 3. And then it was going to grow at about 4.2% per year. So the first 2 years are just given because, again, this is a half year. So it changes the way it behaves. Then the first full year, and then everything else is off of a growth factor. So I'm going to come down here and do fixed costs. So there's going to be 4.2% is the growth rate on that. And then first year is 3 million. Second year is 6,775. And then everything after that is growing. So multiply the previous year by 1 plus the growth rate. Growth rate's down here. I'm going to go ahead and lock that. And you should be good. All right, so it's going to grow to just over 7 million. Then again, Control over, Control Shift left, Control R, fill everything over. Okay, so there's fixed costs. Special maintenance issues for the new existing plant will drive $250,000 costs every other year, starting in year 3, and cost an extra $150,000 per occurrence. So in year 3, we'll have $250,000 in special maintenance. In year 5, we'll have $400,000 in special maintenance, and so on and so forth. Again, you can do this a couple different ways, but I would plug in the first one. Special maintenance. So in year 3 right now, it's saying 250,000. You could go over here and do 400, 550, but that wouldn't be fun. So we're going to wire it in so that we can special maintenance assumption so that it grows by 150 each time. We can do this in a couple of different ways. Equals if odd it's not odd. What is it? This is how I always forget this one. If odd, so the odd function returns the next odd digit. That's not the one I want. It's the so formula identify odd is odd. That's what it is. Is odd. If is odd. Yes. So we only want it to hit in odd numbers years. And so in year 4, it's going to ignore it. But when it is odd, we want 250,000 plus 150,000 times the number of times we've done this. which is going to be times this minus number of years past 3 divided by 1, right? This minus 3 and half. Is that going to do it right? This isn't the only way we could do it. I'm sure if I thought through it, I could do it another way. But that way, when it's 5, it'll be 5 minus 3, which will be 2 divided by 2 is 1. 7 minus 3 divided by 2 is 4 divided by 2, so that'll be the second. So that should do it. And value of false is nothing. We don't want anything if it's not odd. All right, so let's make sure that works. Sure looks like it works. So up 150, up 150, up 150, up 150. There we go. So that's the way I'm going to do it. Is odd's kind of an interesting one. There's also obviously an is even. Is even that does the same thing. I'm going to hit escape and not mess my formula up. But that's the way I'm going to do it. So anyway, again, the advantage there is if they say, oh, actually, that's only going to be 125,000, you can just change it here. It'll update all the ones going through, so on and so forth. But anyway, that's special maintenance. And again, this is the nice thing about having Google, right? If you ever have a formula that doesn't work or it's not quite the formula you want, you just look it up. And I always forget is odd. I always want to do odd. It's not odd. Odd rounds to the nearest odd number or some stupid thing. I've never used that one very much. All right, 7. There is a concern that the new products might cannibalize some of the demand for existing products. Based on correlations of other releases, we believe 6% of new sales will actually be lost sales from existing products that on average cost 82% of the new line cost, but those other lines will cease to exist after year 8. So this is a penalty that only lasts through year 8, is what that last bit means. And basically what happens is if you lose sales, you don't lose 6% of your top line sales. You're actually losing slightly less than that here because you would rather have people buy the new products because the old products they were buying cost less. So you're still increasing revenue, but you're not. So you're not losing the full 6% during the first 8 years. You're losing, you're actually getting 18% of the 6%, basically. You're losing 82% of the 6%, roughly speaking. We could actually be a little bit more accurate than that mathematically if we really wanted to be nerdy about it. So if you think of it this way, so if our new product costs 100, the old product costs 82, is basically what happens. And 6% of our sales, we're losing that 18, or I'm sorry, we're losing the 82 and gaining the 18, right? So you can kind of think of it that way. And so we only get credit for the 18 is basically the point. So part of this revenue is overstated in that particular way. So we can reduce it in a couple different ways. I think it's close enough, though, to just take... It's actually slightly off, but I'm going to do it this way because I don't have time to belabor it. Cannibalization, not a word I spell often, is if we just take 6% times 82%, we're going to lose that much of our revenue for the first 8 years. Okay, so we're just going to reduce our revenue number by a little bit for the first 8 years based on the fact that we're not selling products that we would have otherwise sold. So this product's affecting our other product lines. So I'll put that in here. Cannibalization. We should probably come up with a better word for this, huh? It's not a pleasant word to use. But anyway, so we're going to reduce our revenues by a little bit. Go ahead and lock that. You know, I really should, since I put in depreciation negative, I probably should put all these others in negative too. So that all our costs are negative. I go back and forth. I don't mind them being all, as long as they're all positive or all negative. It doesn't bother me any. But since we started out negative, I'll make them all negative now. It's up to you how you want to do it. But all right, so now all our costs will go in negative since these are negative too. There we go. All right. Current corporate overhead of $150,000 per year will accrue to the new facility plus the cost of some additional hires. At a cost of $145,000 in year 2, growing both costs by 5.5% per year. So this we can ignore. Current corporate overheads, like we said, that's a sunk thing. That's money we're already spending. It's just being allocated. I don't care about allocation. I care about cash. So again, this is an accounting thing, not a finance thing. But we're going to spend $145,000 per year, starting in year 2, growing at 5.5%. We can handle that. So in year 2, we're going to 145. Growing at 5.5%, so that's B34. So again, growth, right? So just multiply by 1 plus growth rate, and then let that carry on through. Oop. I just said we were going to do this, and then I immediately stopped. So we'll carry all those through. Salaries. Tax rate should remain the same, an average of 32.4% based on recent years. So tax rate, we'll hold off on taxes. We'll do that down here because we've got to finish some of the other things first. And our tax is 32.4%. So we'll come back to that after we have everything we need to calculate our net income. Electric usage should increase enough that negotiations with local utility will allow for a decrease in overall rates and reduce savings of $6,000 per month. So we're going to save $6,000 per month in electricity because you move up to a higher load factor or something like that. So $6,000 per month. So electric use, and this is a savings, not a cost. $6,000 per month, which means you need to multiply that by 12. So 6,000 times 12. Except we need to drop 3 zeros. So 6 times 12 actually. And this will be electric savings. In the first year, though, we're only running half a year, so it should be electric use by 2. Then this will equal electric use, and this will equal that. Okay, I'm going to stop here. I'm running out of batteries, and we'll continue on again with another video here in just a little.